Hi my dear students, today we are going to start new chapter, that is chapter number 11, coordinate geometry. So first questions of coordinate geometry, we are going to solve derivations of section formula. It's this section formula in HSLC board exam. It's usually asks us find the coordinates of a point R, X, Y, dividing the line segment joining Px1, y1 and Qx2, y2 internally in the ratio m:n. So now we are going to start solution. So for this question, we have a diagram, a line PQ. The coordinate of P is given in the question as x1, y1. Q coordinate is given as x2, y2. So Q is given as x2, y2. So we are going to find the coordinates of this point R, which divides the line PQ in the ratio m:n. So we are going to start a solution. So to solve this, let R x, y be the point. What is R? R is a point which divide PQ. In some ratio. So let R be the point which divide the line segment joining P x1, y1 and Q x2, y2 in the ratio m:n. This is the first part of the solution. Now to continue this solution, we need construction. What we are going to construct in the figure, we are going to write here. So here we have to draw PA perpendicular to x-axis, RC perpendicular to x-axis, at the same time QB perpendicular to x-axis, and PB, this time it will not be x-axis, PB will be perpendicular to RC. This is construction, assumption. So R, A, B, C, D, okay, we will write as E. PB perpendicular to RC and RE perpendicular to DQ or QB. So we are going to write, we draw, what is that? PA, RC and BQ are drawn perpendicular to x axis at the same time, and PD, and also draw PD perpendicular to RC, PD perpendicular to RC, and RE perpendicular to QB, and RE perpendicular to QB. So we have the given part and we have the construction. So
If it was made very dark and it may not be seen.
it's inside. Here is reflection. You can see.
Can see.
Then in triangle PDR, in triangle three sides of this triangle PDR? We have the three sides PD, ER, and RD. So out of these three sides, in the question it's already given as the line PQ is divided in the ratio m:n. That means PR value is already equivalent to m. So the remaining two sides PD and RD value we have to find out. So in triangle PDR, PD is equal to this PD we can write as AC. Since the length of PD and AC are equal. So in place of AC we can write OC minus OA. In short, we are going to write OC minus OA. We are going to minus, subtracting, taken out OA. So if we minus, remove OA, we still get AC. So in place of AC, we are writing OC minus OA. Next, OC. What is the value of OC in terms of coordinate? OC, since the line is going in x-axis, it's like this, horizontal, x-axis. So the coordinate of this point is x and y. Since it is horizontal, take the x value. So OC is x minus OA. OA, the coordinate of O to A. A is x and y. But since the line is moving horizontal ways, x-axis, take x1. Similarly, we have find the value of PD. Similarly, now RD is equal to RD is equal to this one. So in place of RD, we can write RC minus CD. So what is the coordinate of RC? RC, this time the line is vertical. So you have to consider as y-axis. So if it is y-axis, RC, what is the coordinate of this last point? So when it is y-axis, take the y value. So RC will equal to y minus CD is equal to AP. So the coordinate of AP is y1. So this is the value of the side PD and RD in triangle PDR. And next triangle REQ. In triangle REQ. So in triangle REQ we have three sides RQ, RE and QE. RQ is already given as N. So we have to find RE and QE. RE. What is the value of RE? RE is equal to BC or CD. RE is equal to BC. RE is equal to BC. So similar to the first case, in place of BC, we can write OB minus OC. OB minus OC. Then what is the value of OB? OB is going along the x-axis. So OB, the coordinate of this B is x2 minus OC. The coordinate of OC is x. And the remaining side QE. So QE, instead of QE or in place of QE, we can write BQ minus BE. Then what is the value of BQ? This time we are going to take along y-axis. So BQ coordinate is y2. y2 minus BE. BE is equal to CR. So the coordinate of CR is y. So now we have the value of BD as x minus x1, RD as y minus y1, and REQ as x2 minus x, and QE as y2 minus y. Now consider the two triangles. In triangles PDR and REQ. In both the triangle, there is a pair of angles which measure 90 degrees. This angle and this angle, D and E, measure 90 degrees each. So angle PDR equal to angle REQ is equal to 90 degrees. Similarly, here angle DPR equals to ERQ. Angle DPR is equal to angle REQ. Oh, sorry. DPR is equal to ERQ. ERQ. So they are called as corresponding angle. CORRS. Corresponding angle. So when we consider two triangles, or when we compare two triangles, if two pairs of angles are equal, then by AA similarity, we can say the two triangles PDR similar to triangle REQ. So if these two triangles are similar, if any two triangles are similar, then their corresponding sides are in the same ratio. So for the first triangle, we'll take as PR by RQ equal to PD by RE equals to RD by QE. Now we have the value of PR as M, RQ as N, PD, which we already solved before this, so you can check it back. PD is equal to x minus x1, RE is equal to x2 minus x, RD is equal to y minus y1, and QE is equal to y2 minus y. So after this, what you have to do is consider considering the first part, these two. So M by N is equal to x minus x1 by x2 minus x. So cross multiply. If we cross multiply, M will multiply both x2 and x, and will multiply both x minus x1. So just cross multiply. M into x2, we will get mx2 minus mx equals to n will multiply both terms. So n into x and x minus n into x1. Okay. So now the x term keep together, and 1 and 2 term keep together. So you transferring the term. So after transferring the term, what do we get? Transfer this negative term to right hand side and this negative term to left hand side. So we will get mx2 minus nx1. If it is transferring to left hand side, it will be plus, and x1 equal to mx these two terms, we have x common. So we are taking x common, m plus n. So now transfer this m plus n again to left hand side. Here when we have bracket in the middle is multiplication. If you transfer to left hand side, multiply will change to division. So we will get mx2 plus mx1 by m plus n is equal to x. So the coordinate of x, that is x is equal to mx2 plus nx1 by m plus n. So similarly, this is the coordinate of x. So similarly, we can get y is equal to my2 plus ny1 by m plus n. So the coordinate of x is mx2 plus nx1 by m plus n. The coordinate of y is given as my2 plus ny1 by m plus n. Therefore, I'll just write here. Therefore, xy is equal to mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. So this derivation or this formula is also known as section formula.